In this unit, we are going to be discussing different systems of equations. So we've talked about functions a lot, and now we're going to put two or more of them together and see what happens. Okay, and when you're doing first a linear system, this is two lines, that is, of two lines, there are three things that can happen. First, they can hit at one point, they can hit at no points, and then they could also hit, be the exact same line like down here, like same exact line. So these are the different kinds of possibilities that can happen. So what is the solution to a system of equations? Well, the solution is the point of intersection. So it's always a point. So remember that you always, in a point, you always have an x and a y. A consistent system of equations has points of intersection. So if you look down here, right here, so they either have one solution or they have an infinite number of solutions. So has one or more. Point or points of intersection. An independent consistent system, that's right, I said that, has one point of intersection. And a dependent consistent, that's this one, has infinite number of solutions. Okay? Inconsistent means that they're parallel and there is no points of intersection. Or no solution, we like to call it. So there are three possibilities for answers. Okay, in the end, you get a point. That's our consistent, dependent consistent. Okay, if they're parallel, you have no solution, and what happens at the end is you get kind of two different numbers there, and you can tell that it's going to be no solution. And if it's exactly the same, that means you're always exactly the same number will always get, and it's the same line like here. Okay, so when we're doing these, there's many different ways to solve these, but we like to go through two possible ways, and instead of, that should say two. The first way is substitution, and that's really the best way you could solve most systems of equations. With linear, there is elimination, and it does work, but substitution is the most accurate and the most useful, I guess. What we do first is we solve. So right here it says y equals. So when we have one of the variables equal to the other, and a bunch of numbers, we already know what it's equal to. If I knew that was like, say, y equals 4, I would take the 4, plug it in, and I would get an answer for x. Okay, but I don't. But I do know that y is 3/4 x minus 4. So what I'm going to do is take it and plug it in for this y. There's a y right here, so this whole mess is going to be put right there. So we just simply rewrite it. So we rewrite it 2x plus 4y. But this isn't y. Well, it is y, but it's 3/4 x minus 4. That's our y. This is now here, equals 24. So what I did, in essence, is get rid of the y. And that's what we need to do. You can't solve one equation for two variables. It's impossible. You need two equations. So then we just simply solve this. You distribute in 4 times 3/4, well, 2x, and 4 times 3/4 is just 3x, minus 16 equals 24. Solve. You don't need to hear me speak while I solve. So 5x equals, I'm going to go with that's 40, divide by 5, and x is 8. So we always have a point. So I like to write the point out, and I already got the x part. Now I need the y part. Okay, so what I do is I take either one of those and I put 8 in for x. So I'm going to do the one where it's already y equals. You don't like fractions? Well, then don't use it. It doesn't matter. it works the same every time because they meet at that point. It's two lines and they meet at that point, so that point they share. So no matter what you do, you're going to get the same point. So 2, 6, 6 minus 4, so y is 2. So the system is 8, 2. That's considered consistent. Okay? Okay, method number 2, elimination. So elimination, there's a few things you have to be aware of when you're doing it, is everything needs to be lined up. And the things that you're looking for are the x's, the y's, the equal sign, and the numbers. They all have to be lined up. If they're not, you got to make it happen. So rearrange stuff, move things around, and make that happen. I like to call this one the crisscross. Okay, I hug the tops. I crisscross the 3 up here. So I take the 3, move it up here. 5, move it down there. There we go. Now, what we're trying to do is we're trying to eliminate one of the variables. So what we need to have happen is we have to get one of the variables to be opposite its pair. So this one, when I do the multiplication, this is going to be 15, and so is this. If I make one of them negative 15, say that one, then negative 15 plus positive 15 is 0, and it's going to be eliminated. And that's the goal. Okay, so sometimes you might have negative signs all over the place, and you just have to make sure that when it ends up looking something like this. So you take this negative 3 and distribute it to the whole thing. That's why I put parentheses around the whole thing. We hug it. Minus 12y equals positive 90. And then 15x plus 45y equals negative 90. When we add these two together, this goes away. No more x's. So then we just do 45 and negative 12. So this is 33y. These two actually wind up adding up to 0. So when I do the math here, y is 0. All right, I have one of my variables. I have y is 0. So then I just take either one of the two originals. So there's the original. I'm going to plug the y in for 0. 0 in for y, you know what I meant. And you get 5x equals negative 30, divide by 5, and x is negative 6. And so that is our solution there. Okay, take a second, try this one on your own, and notice what happens. So hopefully you chose substitution here, because this is already y equals. If you like elimination better, that's great, but substitution is the one that you're going to be using consistently. So 2x minus 3 is your y, so you plug that in right there. So you simply rewrite this one with just x's. So 2y equals 6. So y is 2x minus 3. And we simply plug it in and do the math. And what happens here, plus 6 equals 6. So what happens here is these two, 4x minus 4x is 0, and I wind up getting 6 equals 6. So when that happens, we have one number equal to itself. That means no matter what number I put in for x and y, or for x, the y value, these are basically the same. The slope is the same for these two lines. That's one line, and the other line is exactly the same. So what this means is that there are infinite solutions. Okay, so it's not just one, there's infinite solutions. And that's another, what is it, consistent? I don't remember those. So, so 6 equals 6, since the numbers are the same, it's infinite solutions. If the numbers were different, say it was, 3 equals 6, then it would be no solution. They would be different lines running parallel to each other. All right, have a good day.